everyone. Here we are at Max Machinery, and we're going to have Peter and Brandon show us their meter calibration stand. Do you guys want to introduce yourselves?
Sure. You can go first. Yeah, I'll go first. Assembly technician here at Max Machinery. My job is to assemble meters. I do a little bit of beam blasting and sub-assemblies.
So my name is Peter Mischenthaler. I'm the operations manager. So essentially my current responsibility is in charge of all operations, but assembly, purchasing, the testing, the equipment, maintenance, and all that. I've been with the company for about going on 10 years, and I initially started out as an engineer. Over the years, got promoted to my current position.
All right, now we're going to go see how that meter calibration stand works.
Brandon, you want to give just a rough overview of what we do at the calibration stand?
Yeah, so here's our 234 water meter test stand. This is where we test these. These are our 234 meters. And
So basically what we make is high precision positive placement flow meters. And what that is what this guy is. So this is our P234 water meter. It's one of our newer meters that we have. They come in different sizes and arrangements. To get an idea what we have, this is our demo kit that has just kind of samples of our products. Obviously, our meters don't come made out of acrylic, but this just gives you an idea of what it looks like. So this one is our gear meter. This is the Geo15. So it just functions with, has gears on the inside that spin as the fluid goes through, spinning a magnet that's picked up by the transmitter. What that meter is a piston meter, which I guess the closest thing to that, get this out, is this is our 214 piston meter, which functions on the same principle of having 4 pistons. And the way they work, as fluid goes through, the pistons move in kind of a rotary engine sort of fashion. And as it goes, it moves the center crankshaft, which has a magnet. And again, the transmitter picks that up and converts that into a signal, which we then read, and that's how you know your flow rate and how much fluid you've transferred. So yeah, essentially what it is that we do.
And then,
then we gotta, after making it, we have to calibrate it. So Brandon,
yeah, so this is, like I said before, this is our 234 test stand. And how it works is we have the reservoir of water right here. And then it goes down into the pump. The pump pumps all the water through all these orifices over here. And then it comes up over here, puts the water through the meter, and the meter set at a certain calibration to measure the water. And then it comes all the way over here and dumps the water in here. And then we make sure that the numbers on this scale line up with the numbers that would be over there. Make sure they're all correct. And that's how we would calibrate one of these meters, 234.
So the essential, like the basic concept, we have our supply tank at the bottom, which is basically our big bucket, and we'll pump the fluid through the flow meter into a smaller bucket. We'll measure how much fluid we got into the smaller bucket, and by comparing the output of the flow meter, we're able to get a specific K factor, which I explained what K factor is. It's pulses over unit volume, and that's the standard measurement units that are used on our flow. So by measuring how much volume we have in our smaller bucket and how many pulses we get out of the meter, we're able to directly calculate what the pulses per unit volume is at any given flow rate.
So what are these liquid flow meters used for out in the world?
That's actually a very specific question, which we want Eric to give a more specific answer on that. But essentially, I mean, fluid measurement dispensing and I deal with building.
Hi everyone, I'm Eric. I'm the marketing manager for Max Machinery, so that's why I'm answering questions about the sales and where do we put these. Most of the water meters go into items obviously used for water, but if you think about it, when you use water, you flush a toilet, you dump anything down a drain, it goes into the wastewater treatment plant, and there's a bunch of chemicals that they use to put into the water to clean the water. Our product measures the chemicals that are water-based to go into the water. In the industrial world, there's a lot of industrial water use, where again, there's chemicals that are going in so that when you're curing when you build a kayak, they're molded out of a plastic that has a curing resin. They'll use a water-based resin, and that'll go through our meter. They'll use a peroxide-based catalyst. That'll go through our meter. Those are the highlights for these. The other big places that we use them, automotive and aerospace are the other two big places. So everything from Teslas to diesel trucks get our meters used on the testing side of things. Never in them, so we don't sell 1 million of these a year when you sell 1 million Teslas. We sell 10 of these or 100 of these so that they can test 1 million Teslas.
Well, thank you. I don't know if you guys want to show.
Yeah.
Get it going. So we design all the test fans in the house and write all our own software for them. So essentially what it's doing right now is what we call a purge. It is setting the flow rate that it's going through the meter, and it's just to get all the air bubbles out of it. Since we measure direct volume, any air bubbles that are trapped will create error in our measurement. So that just runs for a little bit. All right, starting to get exciting in a second.
All right. Well, while we have a pause, what schooling did you guys have to go through to get your current job?
We want to.
How about Brandon first?
Well, me, I currently go to the JC. I'm taking business classes because I'm built into the sales aspect of the company. So yeah, just general education at the JC for me right now.
So for me, my education is actually in aerospace engineering. In terms of what I need for my job, definitely some sort of engineering degree would be helpful. Because now I'm more in the management side, it isn't as much of a necessity, but definitely since I started with the company in the engineering side, doing automation, having to deal with fluid flow measurements and setting up, sizing all the pipes and devices that are used on the test stands, that education definitely paid off.
Where are we at now here?
So now it's actually going through and doing the calibration. So you can see that there's fluid being poured into the glass. And so this setting are now finished. So what it does is it looks at how much fluid got added to the glass and complete measurement. So it looks at how much fluid got collected, sees how many pulses it collected from the meter, and then it calculates the K factor. So you can actually see here it's starting to output. So we have our flow rate and then the K factor. So that's what the meter is outputting at the moment.
So is that accurate enough, or are you looking for better? Like what are we hoping for?
So the errors that we, in this case, the error limits, we're looking at, so what we look at is how far the meter is from linearity. And so that's over its nominal range, how much the values differ from each other. And essentially, for this calibration, the limit is 1%. It's a basic calibration, and we're currently seeing we're getting well much better than that. We're getting 0.03% right now.
Very cool. Oh, they can't hear. All right, everyone, give us 1 second. We're going to switch devices here so the audio comes through a little bit better.
Hello, everyone. Sorry for the technical difficulties. Hopefully that cleared up some of our audio issues. Now we're gonna head to the Q&A portion of this activity. So please feel free to drop your questions either through YouTube or Zoom, and we will answer them live. You wanna like get in frame, guys?
Yeah.
There we are. And then Q&A. All right, just waiting on your questions. In the meantime, so how has the pandemic changed the manufacturing industry?
So I can't speak for the manufacturing industry as a whole. I can only really speak for how it's impacted us. And it's generally been slow. We did have some months where we were actually doing okay, where we would still hit at about our goal, and then we'd be under. So it's been really hot and cold for us. We're a real niche company, so all of our customers generally are in what's the word? Wow, now I'm blanking on the COVID terms that said they're a business that can't be shut down. They're essential. There we go. So all of our customers generally are in the essential industries. So they kept working, and so we initially didn't really feel much of an impact. But then we started seeing delays in our supply chain, and then orders slowing down. So we've seen a bit of a slowdown.
And Brandon, has the pandemic affected your work personally?
It did in the beginning, but like Peter said, it's kind of a hot or cold type of thing. We get those busy days. When I was shipping too, we would have some busy shipping days, but then I would notice during the months, the shipping days would slow down. We wouldn't have as much stuff to ship, just stuff like that. Nothing too major.
Mm. And we have another question here. Do you offer many internship opportunities?
Our company, we're pretty small, so generally we don't really have much of an internship program. We have on occasion had some engineers come in and work with our engineering department to do some internships, but it's been every once in a while, but it's not anything consistent.
But Brandon, you're Sonoma County local, right?
Yep. Right.
Great.
Yeah. Grew up in Santa Rosa. I'm from Santa Rosa, and then I commute here every day, and love it. Good place to work for.
Awesome. So, what made you want to pursue a career in manufacturing? Maybe Peter can go first.
So manufacturing, I've always done something with some sort of creation process. I've done a lot of carpentry. Actually a lot of carpentry, and that kind of led me to engineering. And so from there, it was kind of just bridged over into manufacturing. Initially, I was more interested in getting hired on for doing the automation side of things. But then as I got more involved in the higher processes and in management, then yeah, it kind of grew more of a liking to the, I guess the management side of the business.
Awesome. And what is it like to be new in the manufacturing industry, Brandon?
There's a lot to learn. I'm learning every day still, and it's neat seeing what goes on behind the scenes, all the production of how they make the meters and what goes on behind the scenes into producing those type of products.
Alrighty. Yeah, of course.
Peter, can you tell us a little bit more about the lab that we're standing in and why there's a popping sound that's coming in the background? Because we're in a live area, live manufacturing area. Tell us a little bit more about what's around us.
Yeah, what you're hearing is because all the stands right now, some of them are still on and they're temperature regulating. So the popping noise is actually, we have glycol running through the building, and it's the solenoid valves opening up to let glycol flow through the test stands. Prior to that, you were actually hearing the valve on this particular test stand. It was firing. So we used a combination of servo-driven and pneumatically driven valves and controls. So when you're hearing the popping noises, it's usually the pneumatics.
And since we had some video quality issues earlier, would we be able to see the meter a little bit closer? The laptop?
Sure. Look at this guy. We can pull some out of the demo kit if we want to actually look at the internals.
So this is where we would plug in the cable. This is where we plug in the pulse cable, and it would give the read.
That was just where you get your output and
Yeah,
power
where
in.
you get your output and power in. And this is the 234 water meter. So this is the one that we test on this stand right here. And then Peter has these other ones right here. Show there we go.
All right, so going over it again, we have, this is our gear meter. So that one was a piston meter. This one is our gear meter line. And it functions by having two gears on the inside of it, which as fluid goes through it, spins, rotates a center shaft that has a magnet, and then picked up by the transmitter and generates a signal based upon that input. Then to kind of get a clear view of that piston, this is the 214 piston meter. You can see as I rotate the crankshaft that the pistons rotate in kind of a rotary engine sort of way. So the way this one functions, fluid comes in through the inlet, goes through all the chambers, pushing the pistons essentially like a syringe, and rotating a center crankshaft that has a magnet. Transmitter picks that up, converts it to a signal. Very cool. And in case, while I still have the camera, if you're curious, the test stand is actually still running. So you can get an idea of like how low this one goes down to 3 cc's a minute. So our meters literally will measure drops. And so this one will go about a factor of 10 smaller than what you're seeing right now.
So we have one more question.
right.
When you explained that shipping was slow due to COVID, are your products shipped worldwide, or do you have a specific region that you ship to?
Yeah, we ship products worldwide. China, Japan, any countries. Yeah, any countries. International.
Wow, that's
There's
pretty
a lot of
neat.
international shipments.
Okay, so thank you all for coming to the virtual activity and watching Peter and Brandon do what they do every day. Have a great rest of your day.